My guest today is Rich Heimann, a visionary leader in artificial intelligence and business transformation. As a chief artificial intelligence officer, Rich has a proven track record of developing and deploying AI solutions that drive measurable impact across a range of industries. Known for his ability to blend technical expertise with strategic insight, he consistently helps organizations unlock the full potential of AI to achieve real business results. Rich is also committed to ethical AI practices and excels at building innovative, high-performing teams. He's recently authored a new book titled Generative Artificial Intelligence Revealed. Thank you so much for being on the show with us, Rich. It's a real honor to have you here.
Yeah, likewise. Thanks for the invite.
So you've been working in data science and artificial intelligence for some time now. What initially drew you to this field before it was the hot new sexy that everybody was trying to participate in?
Yeah, good question. Nothing really.
Okay.
I kind of fell into it. My background is in statistics and geography, so I was kind of working on computational social science projects for a long time, using spatial econometrics, and I spent a lot of time at the Naval Research Lab, working on like these statistical methods to try to predict like the location of IEDs, and I spent some time at the Metropolitan Police Department, analyzing sort of like point patterns and crime data. And I ended up, just like working with machine learning. I joined DARPA to work on effectively a computational social science project, a project called Nexus 7, which was doing kind of like population level data analysis and data mining, trying to inform sort of like the NATO leadership on how to, what was going on in the country with respect to military operations and even like civilian, kind of like winning the hearts and minds kind of operations. And that was, most of my time there was spent effectively spatializing machine learning models. And that was like my introduction, at least like notionally I was familiar with machine learning, but that was I guess I cut my teeth on machine learning on that program, which was about 12 years ago. That program was pretty successful, and it rolled into another DARPA program called Network Defense, where we were using machine learning to find aberrant behavior in network traffic. Might resonate with you and your audience. And that was my introduction to cybersecurity, and that was about 10 years ago. And so I've been working in machine learning for a long time, still kind of oblivious to what artificial intelligence was. And then we started a company called Cybersecurity, which was built on the intellectual property that was created at DARPA, specifically on the network defense program. And so I remember distinctly, I was a chief data scientist at the time, and I distinctly remember a conversation with a marketing guy who was like, "What do you think about calling our work artificial intelligence?" And I'm like I really don't care. Like whatever you want to call it, you want to call it. But it immediately created a bunch of like internal strife on the team and like arguments about what was artificial intelligence and whether machines understood. And it was just foreign to me because that was the first, this is probably like 2016, 2017. And so that was the first time I was kind of like introduced to all the baggage that's typically associated with artificial intelligence. And you know, I think the reason why it caught me off guard is because, you know, having a stats background, statistics is entirely applied, right? So yeah. It's really like, how much impact does your statistical model have on problem X? And you know, like you never attach any like anthropomorphic kind of qualities to the statistical model. There are no other goals for the model besides like problem solving. And so I think, you know, I think that's what, when I say it caught me off guard because people started like attaching things to this name. And that, you know, that sparked an interest in me of like, you know, what was AI? And so, you know, I just started reading some of the literature, sort of classic, and then more of the contemporary slash modern coverage of the topic, and ended up writing a book in 2020 called Doing AI, which was, you know, after a few years of really trying to immerse myself into AI And what I mean by that is like from the perspective of insiders, like people, AI researchers, and how they view their work. And after a few years of kind of like immersing myself in that perspective, I wrote a book on like why those goals, the goals of insiders, friends of artificial intelligence, I like to call them, like the diehard kind of people that believe in artificial general intelligence and maybe these takeoff scenarios, et cetera, like why those goals are generally misaligned with most business problems. And to some extent, this most recent book is just building on that work from 2020.
Very cool. And that's probably an interesting spot to start. I have my own idea of the difference between machine learning and artificial intelligence, but it's pretty fuzzy. Is there any kind of line there, or is it just a gradient and it depends on your perspective?
Yeah, that's a good question. Practically speaking, most people probably just conflate the two. Like, they're kind of like these synonymous terms. Practitioners might gravitate to machine learning, where, I don't know, literary experts, like those people who are posting online all the time about all the great things that artificial intelligence could do, will probably lean to the artificial intelligence. But I think the important distinction is, as I'm kind of like I'm trying to articulate, however poorly, is that I think specifically with artificial intelligence, what you're talking about are a bunch of external goals. So it's not just that a solution, let's call, a solution could be machine learning, it could be an expert system, it could be a rule, it could be an algorithm, sort of like non-machine learning algorithm, it could be a statistical model. Artificial intelligence, I think, suggests something very specific. And it's not just like, oh, we're going to solve a problem, but we're going to solve it in a very specific way, which is like, in a way that we can make like credible claims about its intelligence or how general it is. And so that's why I generally try to avoid the term, just because it has a bunch of baggage. Marvin Minsky, who is one of the founders of the fields going back to the 1950s, famously called artificial intelligence a suitcase term. I don't know if you're familiar with this, but I think what he was trying to underscore is just like all of this baggage that's typically associated with AI. And, going back to the story of the marketing guy wanting to call the work we were doing at Cybersecurity AI, I think, and the internal strife it caused in the team underscores a lot of that baggage.
Yeah. I think in cybersecurity specifically, there's definitely like some AI baggage where people were throwing this term around for years and years. And now we're actually seeing some interesting stuff come out, but people are kind of fatigued from having that term thrown around so much already.
Yeah. Yep. And so, so one of the reasons I wrote this most recent book, where like doing AI, this is 2020. There was a lot of hype and like these unmet expectations. Machine or artificial intelligence now has gone mainstream. I mean, we're talking about language models, and they're being used. Well, language models and I guess text to image models, like diffusion models, are being used by millions, tens of millions, maybe even hundreds of millions of people. AI, after like 70 years, has finally gone mainstream. And yet we're almost like at peak levels of skepticism too. And I think some of that is because people are just, they're tired. They're just like, they're over all of the talk about artificial intelligence and like, AGI in 2024 and AGI in 2026 and AGI in 2027. And they're just fatigued. And and I think that's where some of the skepticism is coming from.
Right. For me, it was, I think, back in 2015 or so when AlphaGo beat the world champion in Go. I thought that deep learning was going to be the thing that brought AI mainstream and kind of changed the world. But it seems that LLMs kind of came out of left field and have become the thing that's sort of leading the charge. Can you maybe talk about the differences there and maybe any ideas on why deep learning has been this thing that's kind of in the background still?
Yeah. Well, I think they're incredibly versatile, and they could fit a function just about any data. I think the prevalence of language models has less to do with the architecture, although the architecture is impressive. I mean, I don't know how closely you followed the technology, or whether you use like some of the early models like GPT-2. They weren't great. Like, they were certainly better than RNNs and LSTMs, but they certainly didn't perform at the level that you see in GPT-4 or even GPT-3.5. But what I think has happened over the same period of time are not like these. It hasn't really been like a revolution in architecture. They're in many regards, they're very similar architectures. I think what has happened is that instead of training these models on these small, generally boutique type of data sets, we're now training them on the internet.
Yeah.
And the internet, it's multimodal, it's multilingual, it's multitask. And, much of the improvements in performance, I think, could be tied closer to just the data, not constraining the model's performance and offering kind of like this flexibility in this multitask environment, than it is the architecture alone. And so, what's happened over, especially the last like 4 or 5 years, is we're just training the models on a lot more data and a lot more compute. And that has positively impacted their performance over a variety of tasks.
Mm-hmm. Yeah, I find it interesting too. Like we're trying to understand it and trying to figure out how we can leverage it to have better security outcomes from folks. And the generative stuff in particular, I find very hard because it's right 99% of the time and hallucinates 1% of the time, and now you can't use it. So I've been trying to leverage things like RAG, which constrains the data that comes back. But even in that, there's still this inherent flaw in the system where it will make stuff up if it doesn't have the answer. I don't know what the solution is there.
Yeah. Well, if you figure it out, let me know. Wow. Yeah, I mean, it's tough. I think the misconception people get in when they're like casual users maybe of the technology is they think a lot of the success of language models is just going to be like crafting the killer prompts.
Right.
And like that's the thing to fix the problems. However, with that outlook, what people kind of overlook is that the output of the models, like the content that they generate, is still, largely predicated on the training data. Mm-hmm. And so the prompt is really just a clue. Like, how can you, or the prompt specifically, like navigate the internal representations of the model? However, if the prompt deviates significantly from like the dominant patterns in the training data, you're going to see goofy behavior. I think that's like commonly where you see a lot of hallucinations, and RAG, of course, is like one way to mitigate that. You're effectively trying to augment the model with some external access to an external knowledge base, which certainly assuages some of the hallucinations, but I don't think there's one way to eliminate it. Even if you stack a bunch of complementary solutions together, maybe it's like, prompting, prompt engineering, RAG, maybe you're even doing a little bit of fine tuning, although sometimes fine tuning can actually aggravate the hallucinations. You could certainly impact it, but 99% performance sounds pretty good to me. I think it really comes down to what kind of domain are you working in, and whether 99% accuracy is good enough in a specific problem, is out of a specific domain, or whether, you need to be perfect. And if you need to be perfect, the application of language models, I think, is always going to be tricky. If you need to be perfect, the application of almost any technology is going to be tricky.
Sure. Yeah.
I mean, I think any probabilistic, non-deterministic, kind of solution is always going to be tricky in those domains.
Yeah, I think 99% was generous, but yeah, I get your point.
Yeah.
You kind of alluded there that maybe the hallucination comes from when the model is sort of missing some data, and that's where it's making stuff up. Is scaling the models a way to address some of this? Do we just need to put more data into them?
Yeah. Yeah, definitely. Hallucinations have gone down as scale has gone up. And I think the reason why that happens, I don't know. To some degree, this isn't exactly speculation, but I probably can't point to a single paper or some sort of research that reinforces this, is that, larger models just inherently have more capacity, and they have more capacity to learn kind of like tail knowledge.
Mm-hmm.
And so it's not just like, I think when you're training a smaller model, the intuition behind it is that you've just got less room for the model to learn things. And so it's going to tend to learn the most dominant patterns in the training data. Whereas a larger model is going to have more capacity. It's just like, you've got a bigger library, you fit more books, and consequently you could fit a lot of like rare or niche kind of books onto those bookshelves. And it gives, I think it, in those scenarios, you have the ability to impact the hallucinations, the performance of the model really in the tails of the distribution, which positively impacts hallucinations. I would probably add that, you're still going to have tails even in that scenario. It's just extra capacity where it could perhaps find room for tail knowledge. I think, a lot of people are working right now with synthetic data, and I think people are optimistic that for those domains or those areas of the model that are, it basically has like underrepresented training data, that synthetic data might be able to create data to augment the underrepresented portions of the training data set. And that might also impact hallucinations. They've certainly gotten better over the last number of years, hallucinations, that is. So I would expect that trend to generally continue, that hallucinations are going to become a smaller and smaller problem, probably never going away, however.
Yeah. In your book, you talk about this, and I think you kind of made a good analogy there with the library as these models being like the data compression is the best way to think of them, and to avoid attributing human-like qualities to these systems. Why is that difference important in the way we think about them?
Yeah. Great question. So I like the compression idea, one, because, not just compression, I guess, in an abstract sense, but compression in the specific regard that these models are effectively compressed versions of the internet.
Sure.
And I think that helps people remember that, like, if you are working on a problem, let's say, you want to prompt the model with something, and, you were to prompt a search engine like Google with the same kind of prompt, and you get back very few search results. If it's the kind of task, even if that's like only notional, it's some sort of like thought experiment that you perform in your head, I think that will give you some indication of like where the model is not going to perform well. Like if you search for something in Google and you get no results, or you get 100 results, or even 1,000 results, those are the same kind of problems I think that language models are going to generally struggle with. Smaller models especially, because again, they have just less capacity than larger models. And that's not a death sentence perhaps for the application of language models in that specific domain or on that specific task. It just requires you to think a little bit differently about the application itself. And maybe that's when you start thinking about the application of like prompt engineering or RAG systems, some other way to like get that knowledge, or even potentially like training a model from scratch or fine tuning to get that information to the model. So it could perform a little better on the task.
Yeah, I've had a lot of success kind of layering techniques on top of each other. I
For
find
sure.
that like one like a RAG is good for pulling back that initial data, but then feeding it back into like a prompt can actually make the results a lot better.
Yeah, exactly. And on that point, yeah, great point. On that point, I think starting off with like the advice I generally give to people who are experimenting with the technology is, avoid training, avoid fine tuning, use those as kind of last resorts. First experiment with the model, start off with like the most capable models. And then like that you need to deploy a model on-prem and it's an open source model, like then start to scale things back to the kind of like the model that you're thinking about adopting to see where the performance starts to degrade, if at all. But then, also if it's, if you're unsuccessful, start experimenting with prompt strategies, advanced prompting strategies, and then go to RAG. But don't just, start with the cheapest, easiest solutions that don't require you to train a model, as basically my advice, because that's really hard to do.
Yeah, and expensive and time consuming. So memorization is a lesser known but important concept in AI. Can you explain what the phenomenon of memorization in generative models is and how it differs from overfitting and why it's significant for understanding how AI models function?
Yeah, this is, I think, still something that it's not commonly known, and there's still a lot of questions, I think, about memorization. We wrote about it. I've been writing about it for the last year or year and a half, and I think people still kind of assume. I think generally people have kind of like this hope or idea that that like machine learning assiduously generalizes from the training data, but it doesn't. It actually has a tendency to memorize verbatim some of the training data, depending on the size of the model and how frequently that data is repeated in the training data and for how long you train the model. But the estimates range from about 1 to maybe as high as like 5% of the training data is memorized by the model, and that's different than just overfitting, which is a problem in and of itself. I think in both cases, what you're talking about is something that subverts generalization. But the memorization, specifically memorizing the data verbatim, is kind of like this double-edged thing that is both bad because the model is not generalizing from the training data, but also good because it positively impacts model performance. I saw a really interesting paper that was looking at this problem, and what I thought most fascinating about the research is that they looked at the memorization of the training data across different models and even different training data sets, and they found that there was a 50% overlap in what was being memorized, suggesting that there's maybe even something about certain kinds of data that just have kind of like this inclination to be memorized.
Interesting.
Which I find fascinating, I guess. But
it's like almost the way that humans can remember phone numbers in groups of 3s and 4s. It's kind of fit to our brain, right?
Yeah, great observation. I hadn't thought about it like that, but I think that's a great analogy. It's goofy at this point. The problem with memorization is, one, I think it presents some complications to copyright infringement. I mean, obviously, a lot of these companies are declaring fair use doctrine for using the internet, using data that they found on the internet. If you're going to recreate that data verbatim, I think that presents some interesting complications from a legal perspective. The other challenge, I think, as it relates to memorization from a practical standpoint, not like a theoretical, there's a 50% overlap in some of this data, is from a security perspective. So a lot of organizations want to train they want to adopt generative technology. They want to train these models on their corporate data, But then the question is, okay, well, now it's memorizing some of our corporate data. How do we manage that? And I think that presents some interesting complications for adoption in a corporate environment.
Yeah, I know ourselves have just sort of published our internal AI policies on how to use it. And it's basically we keep all information that's not public out of the models because there's no guarantee that stuff doesn't get absorbed and bubbled up in some way.
Yep, right.
Do you think the copyright laws are going to need to evolve to change this? I know this is probably outside of your purview, but
I would probably defer to a lawyer. That's why I teamed up with Clayton because he is a lawyer. So I would probably dodge that question. I know I do have kind of opinions, and I'm going to avoid the question.
Okay.
Just because it's such a polarizing topic.
Yeah.
And I don't want to get too far out over my skis on something that I may not appreciate completely.
Okay. Well, I might bug you for Clayton's contact so we can get him on the show because the legal side of all this stuff is always fascinating, especially in security. Like there's all this data leaks on the web. Is it illegal to go get it? Can I look at it? Can I, just like where are the lines? Can I access a bad actor's computer, which I'm pretty sure is no, but like I should be able to. And
yeah.
Yeah.
Well, I think, 10 years ago when we were building data science teams, these questions, these are questions we weren't asking. And I think as a consequence of generative technology going mainstream, there's just so much more attention. A lot of that attention is good. You're obviously, some of that attention is from investors, which I think is generally good. Talented people want to work on this technology. I think that's generally good for the technology. It has also caught the eye of regulators and government officials. And that's not always good, but in this case, maybe it is good. But I think maybe in your introduction you were talking about the composition of data science teams, and I was just having a conversation a couple of days ago with somebody who was asking the question, has that changed? And I think it certainly has changed, and specifically on these quantum switch teams, I think data science teams are going to have to be working more closely with legal experts and understanding the governance that's required in deploying these models.
Many AI professionals are discussing the emerging role of prompt engineering as a crucial skill for getting the best results from these language models. Can you explain why prompt engineering is so important, how it influences the quality of AI-generated content, and maybe also how it's not the solution to all the problems?
It's a good question. Prompt engineering is certainly annoying. I'm sure anybody who's used the models regularly, especially using the models for product development, understand how frustrating it is working with language models because they respond to almost everything in a prompt, and that's frustrating. I don't know if you've seen these social engineering prompting strategies where it's the best thing to do is to tell the model that you're going to get fired if it does something wrong, or I'll give you a $200 tip if you get this right. And what the research has shown is, one, that doesn't positively impact the performance of the model, but it does influence the behavior. And in fact, almost everything you put into a prompt affects the behavior. And, sometimes you just don't want something to be so sensitive to a prompt. But in another regard, that's how they work. They work based on the clues effectively that you are providing or dropping into the prompt. And so it's always this double-edged sword, at least from my perspective. It's oh man, I guess you end up, it's a very iterative process. You've got to create a prompt, and you're going to be revising that prompt, and sometimes you'll oversteer and overcorrect, and it's just frustrating. I'm not sure. I think I answered you with an emotion. I think I answered your question
an emotional response.
My frustration than a specific answer to your question.
Yeah, that's fine. Have you seen any of the prompt injection stuff taking place, like the way people are exploiting these different services and stuff.
Yeah.
Yeah.
Yeah. I mean, that's another hazard of using internet data. I mean, aside from the fact that the internet wasn't created to train language models or to train machine learning models, generally speaking, and some of that information obviously is copyrighted. There's toxic information. There's other kind of like biased, racist, sexist, toxic / problematic content. Is that, as this thing goes along, that is like, subsequent iterations of training new models on new snapshots of the data, I think you're going to see more and more kind of like indirect prompt injections where people are just throwing stuff out on the web that is going to be consumed by a language model, and they're going to have prompts that are influencing the behavior of these models and may never be seen by a person. And so I think that's going to be interesting.
Yeah, I find it fascinating too. If you think about how much content out there on the web, I think the last estimate I saw was around 50% of new content on the web being AI generated.
Yeah.
And then you think about that being fed back into the model, like at which point does it become a snake eating its tail and poison itself?
Yeah. Yeah. The model collapse scenario.
Yeah.
I think there are a couple of things to worry about. One is you're training the data on the public internet, and you are going to have, you have a security background, I have a security background. It's not hard to imagine exactly like all the things that are going to be just embedded into web pages that are going to influence the model's behavior. That could be from a political perspective. It could be from a financial gain perspective. I mean, there are so many things that could be done to poison, I guess, like subsequent iterations of training models. The other problem of using the internet is that all of these models are trained on the internet. And so they've all effectively learned the, very similar representations of the data, which means that even like the direct prompting strategies tend to be successful across all models. If you understand what I'm saying. And that's just a consequence of, using the same data, machine learning, the algorithms themselves. Like, even though we talk about hundreds of different models and different sizes, they're very similar architectures and they learn very similar model representations. So if you could compromise one model, you could effectively compromise all models, which is problematic. And then the model collapse scenario, I think that's a little more, there's a little more speculation involved with respect to the model collapse. But yeah, it's a potential scenario.
For the listeners, can you expand on direct prompting?
Yeah. So direct prompting is kind of like the jailbreak scenario. Like you're basically trying to influence the model to break out of its guardrails. And like basically, sometimes you just try to get it into a different persona. Like, you're the evil language model and you're going to do everything I say. So that's just like a direct prompt. An indirect prompt is, you ask the model to go to the internet, fetch a web page, and in that web page, or maybe you upload a document, in that document, there's an embedded prompt, and the model consumes that prompt and that influences the behavior. Usually that's done by a third party. So, you're doing it for, to I guess, interfere with somebody else's interaction with the model.
So many companies are looking to adopt AI through software as a service models, which can provide access to advanced capabilities without having to build these systems from scratch, which I think you recommended earlier. What are the most important factors businesses should consider when going down this route?
Yeah, probably not over investing at this point. When I think about the technology, it's certainly come a long way over the last couple of years. And I think it's going to continue to move pretty rapidly. And so my advice to businesses entertaining the technology is to sort of think about their long-term positioning. So certainly get started with the technology. I think the SaaS kind of adoption model is the most appropriate in the near term. Use like the commercial foundational models to start to evaluate different different use cases, figure out which ones might have the kind of ROI required. It allows you to sort of like dip your feet without over investing. In the book, I give the example of like what Bloomberg did, I think, in maybe it was late 2022. And so Bloomberg was really excited about the release of ChatGPT, and they downloaded an open source model, and they had a lot of corporate data, as you would imagine they would, since it's Bloomberg. And so they trained a model from scratch. And so this is like just a couple of months after ChatGPT. I think it was just a couple of months after the release of ChatGPT. May have been a little bit earlier, in their defense, perhaps. But, what they ended up doing was, they spent, probably 4 months on getting their data ready to train the model. And then a couple of months training the model. They spent $1 million, and they had a model that was more capable than the model at the time. And I think their baseline comparison was similarly sized model. So I forget what that was exactly. I think it was a 50 or 60 billion parameter model. And I forget what performance they were baselining it was, but it wasn't Llama 3, which is a very capable model at about 70 billion parameters. It was whatever model existed at the time. And so, I think in that scenario that maybe it worked out for them. But I think generally that's a bad strategy, especially when technology is changing so rapidly. They spent $1 million when they could have just used a commercial model and maybe a RAG system, and saved a lot of money to figure out, how well this model performed before like really dipping their feet into retraining a model from scratch. But they also missed out on better models, higher performing models, like the aforementioned Llama 2 and even Llama 3.
And kind of getting that free come along with the ride kind of thing when you're investing in a commercial model that's being evolved by that company, and you get to kind of get the benefit of the evolving technology.
That's it. Yeah. Bigger context wins is like you didn't have to do anything but upload, but update maybe one line of code, which is like the API call to the new model.
Yeah.
And maybe that's not a viable long-term strategy, but certainly short-term strategy especially for the companies that aren't Bloomberg, that are unsure exactly what corporate data they have or what corporate data might be relevant. Maybe, their environment is siloed, so they may not even know where all this data is. They may not even know what use cases are going to be valuable. And so, for those organizations, I certainly think there's a strategy of like over-investing in the short term. And it's not just like in the short term, you're over-investing, you're spending money, and you're missing out on the benefits of future advancements. But, you could potentially like subvert your appetite for future investments. Like if that goes sour, a whole management team might look at like any future investment with skepticism. So basically my idea is you've got to invest, but just don't overinvest in the long term. Think about long-term positioning and where you want to be in a couple of years.
And I think we've probably done our listeners a disservice. We've mentioned RAG at least a dozen times and haven't explained what it is. So retrieval augmented generation. This is a method that's gained a lot of attention recently. It's one that I leverage a lot and I think is the best use case I've seen for LLM so far. Can you maybe explain how RAG works for the listeners and which challenges business might face when implementing it effectively?
Yeah. So the idea of a language model is that you're going to interact. What makes it so appealing, I guess, to many people is that you could interact with it using natural language, right? So it's really intuitive. We said prompt engineering is frustrating, but certainly like in an afternoon, you could get the handle of it. You kind of get, you understand, you're interacting with a model, and immediately you get like feedback on how those things influence the model's output and subsequent behavior. What we've also said is that language models don't just respond to their prompts, they're also responding to the training data. And so if you're working on something that's underrepresented in like a general web search or the like free internet, then, the task, maybe it's got specialized language. The model's not going to do as well in those domains. I was actually working with a really large media company, and they're adopting the technology. I just did a series of like webinars for them on prompt engineering, and, people were generally excited about using the technology, but it was just that, they were just doing an API call to ChatGPT. They had like their own interface, but it was, it was ChatGPT with a wrapper.
Yeah.
I don't mean that in a derogatory sense. I think their actual adoption strategy was pretty good. It was just exploratory. But a lot of the people were frustrated because they were, at this media company, employees at this media company were frustrated because they started searching for things that were like internal kind of documents or tracking. They had like ID numbers that were tracking certain things inside of the company. And they're like, oh, the model's dumb. It doesn't know any of this stuff. And I'm like, yeah, that's because that data is not just underrepresented in the training data. It's not in the training data. Like the model doesn't know anything about you or your organization because the model wasn't trained on any of your data. But one way you can mitigate that is with prompt engineering. You put the information into the prompt, and the language model kind of works in this in-context learning scenario where it's taking, bits of information from your prompts and using that to kind of navigate its internal model representation to give an output. And they were pretty satisfied, I guess, with that explanation. But that idea of prompt engineering is just, okay, well, I've got access to external information. I'm going to bring it into my in-context learning environment. And I'm going to work on a task. You can extend that to a more dynamic environment using something called like RAG. And RAG does nothing more than it takes your prompts and it ships it off to an external data source that has external knowledge, typically like, domain specific or corporate information. That information has, it's in a vector database, at least a canonical example. Actually, maybe all the examples of
that's how we're using it.
Yeah. Okay. So you chunk up the data into vectors, use vectors to create word embeddings. And then you're basically doing some sort of like retrieval between the prompt, your query, and the documents that are in the database. And what happens is that information is extracted out of the system. It's thrown into the language model, and you're basically combining the context with the prompts. So hopefully that's pretty intuitive. The most common, I guess, setup or architecture is the BM25, which is, you're gonna create chunks of the data, you're gonna index them, you're gonna create these word embeddings, and then you're just doing cosine similarity between the prompts and the data inside of the database, and that works pretty well. Mm-hmm. It's certainly like the cheapest and most common kind of deployment. It's always a great place to start. And then they're all like different sort of like variants of like the basic BM25 setup.
Yeah, it's very cool. I found it a great way to like the fine tuning when I experimented with it before. It just wasn't giving me the results where this, I find it's much more tuned in. And then I take the results back from that and I send it back to the model with another prompt to help it determine which part of the data coming back is the most relevant.
Yep. Yeah. And what's great about RAG, which I think we've already underscored, is that it's cheap. Like cheap in the sense that you don't have to train or tune the model.
Yeah.
And in fact, if you wanted to tune the model, I've seen a lot of examples of people using the RAG system to help generate the tuning data that they use to then fine tune their model.
Yeah.
And but the idea again is just you have these external data sources with external knowledge, and you want to bring it closer to the model without necessarily like updating the parameters of the model. And so it's a great first step. And then they're all like different ways where you could kind of like build onto your RAG system after that.
In design, there's a concept of skeuomorphism, where new technologies mimic the appearance or functions of older ones. How does this apply to AI development, and why is it important for companies to be aware of this when creating their own AI applications?
Yeah. Okay. Yeah. So this is the last chapter of the book. The reason why I started writing about skeuomorphism, I'm going to give you, I'll try to do the abridged version, but there are two ways to think about skeuomorphism. So the reason why I wanted to end the book with this idea of skeuomorphism is I really wanted people to appreciate, specifically like business and business leaders, to appreciate that that innovation is slow and it's incremental and it's adaptive. Like it's not this. A lot of times we talk about artificial intelligence and we talk about like this bang or intelligence explosion, these like weird takeoff scenarios where like the model will suddenly acquire intelligence, or it will like go through some recursive self-improvement process, and it will become, it will create these utopian scenarios or dystopian scenarios. The truth is none of that's going to happen. It's going to be super slow, and mainly because people like us, your listeners, like you, you have to learn the technology. You have to learn how it works, why it doesn't work. You have to work with prompt engineering and figure that out, and prompt chaining and prompt templates. And then you're like, oh, what is this RAG thing? And now you got to figure out RAG, and RAG doesn't work. So you got to figure out other kinds of RAG that do like re-ranking and re-indexing of the data. Anyway, the point is like, you're like, okay, well, I need to do this other thing that doesn't exist yet. I got to build that technology. And so what I was trying to explain with RAG is that innovation typically takes on these like skeuomorphic ideas, and they generally look like things that have existed in the past. Like the first iron bridge was built with woodworking techniques. Mm-hmm. And like even now in language models, what do we see? We see copilots. And copilots are nothing saying then like, oh, there are software developers. We're going to create a copilot for software developers. And it's because we don't know anything to do yet. And so we do the most obvious things. Even the internet was filled with a bunch of companies that just existed in the real world. And they're like, well, let's just put them online. And it's like, okay, they're the least imaginative ideas possible.
Sure.
But they're also like, okay, I understand why you went there first, because you already understood that business or that design technique. And so you just try to replicate them with the new technology. Eventually you break free and you think about the technology in like new innovative ways that take advantage of like the native design of the technology. And the whole concept, I did a better job writing this than I did speaking it, but I'm doing speaking it right now. But, the whole goal of the last chapter was to kind of push back on skeptics. I don't know if you've seen the recent articles by Goldman Sachs and Sequoia Capital.
I haven't read them, no.
Okay. Well, they were asking, like, where's the revenue? Like, we're 20 months past ChatGPT, and the skeptics are asking, why isn't there more revenue?
Right.
And I think that, like, this is the thing why I wrote the book, was because there wasn't just hype anymore. There was a good degree of skepticism, and I think it's causing a lot of people to be kind of confused and maybe even anxious about the technology. Should I adopt it? Should I not adopt it? And these sort of like competing narratives is what like kind of motivated me to write this book. And specifically the last chapter is like pushback on like skeptics who are like, these things should be happening faster. But those people generally have clean hands. Like they're not working with the technology directly.
Yeah.
And what I want to encourage people to think about is innovation is incremental and it does take time. And it's because, humans need to learn things, and they need to figure out how to use the technology for their business and for the new use cases. And so, I use skeuomorphism as just a way of explaining how painfully slow innovation is. Yeah. And that we build iron bridges with woodworking techniques because at the beginning, that's all we know how to do. And I think to a large degree, most of the generative AI is like we're building iron bridges with woodworking techniques.
Yeah.
You know what I mean?
Yeah. No, and I love that example because it makes me think back to like early in my career was sort of when smartphones became a thing and everybody was rushing in to build apps for phones and stuff. And all the early apps looked like the real world equivalent. So if you had a note taking app, it looked like a physical notepad with like a little spring at the top of the graphic and stuff. And then, a few years on, people understand the technology, they absorb it, and now note-taking apps look like they're natively built on the phone and there's no reference to the real world. And I think that's a similar kind of pattern that you're talking about.
Yeah, exactly. Yeah, I mean, that helps the user, right?
Yes.
So the user can see the notepad that looks like a piece of paper, even though, why do you need that? Why do you need something that replicates a piece of paper on a digital phone? But it helps the user adopt the technology because they may not know how to interact with the technology. But I also think the idea applies to problem solvers because problem solvers don't always know how to use a technology. The Iron Bridge is a great example. Like it took us 100 years to develop riveting, which now obviously we're going to use, riveting
Rivets,
when we're building iron bridges. But it took someone 100 years to figure that out. Now, I'm not saying it's going to take us 100 years to figure out how to use, maximize the utility of language models. Yeah. But it's certainly going to take time. And people writing these articles about where's the beef, where's the revenue. Yeah. It's just okay, that's an arbitrary timeline. Nobody said that after 20 months, we would have $1 trillion of GDP added to the global. Let's take a breath and let people figure out how to use the technology natively. Yeah.
And the VC's expectations of these kind of things is quite detached from reality sometimes.
Unhinged. Often unhinged. And it's because they're not always builders.
Yeah. All right. So this is the last one I have for you. It's the one I ask of everybody that comes on the show. It can be as wide or as narrow as you want. I'm pretty sure you answered it the first time you were on the show over a year ago. Do you have any predictions for the future of cybersecurity?
I think I hated this question the first time you asked it. I think it's going to look a lot like today, mainly because innovation is slow and it is incremental. And so, I'm a skeptic as it relates to these takeoff scenarios that AGI, I posted something on LinkedIn today, or maybe it was yesterday, and it was something like somebody's tracking the countdown to AGI and it's at 81%, whatever that could possibly, I don't even know what that could possibly mean, but I don't think any of that is going to happen. I think it's going to require people like you and the team at LimaCharlie and others who are just working with the technology to figure it out. And, everybody's going to collectively push the ball down the field. But it's going to be pretty slow. I think that being said, I think there's still a little left in the juice with respect to scaling laws. And so I think you're going to see another iteration or two of even larger models trained on even more data. Some of that data, maybe even synthetic data. So I don't think the performance of these models had been squeezed out entirely. 1L was just released, I guess, earlier this week or last week. And that was trying to basically codify chain of thought reasoning into the model itself. I think you're going to see improvements. I think, a lot of people are interested in making these models at least a little bit better with regard to planning and reasoning. So that's going to improve, but it's going to look a lot like things are today.
Rich, thanks so much for coming on the show with me again. It's been great talking to you. It's a fascinating subject for me, and I think probably provided a lot of value for our listeners. So,
yeah, I hope so. I appreciate it. Yeah, with respect to the book, it is available on Amazon. It's also available for free as a download if your listeners want to just visit the book website and they could download it there.
Okay, awesome. I'll get the link from you and we'll put it in the show notes for everybody.
Awesome. That's great.
Okay.
Thanks, Christopher.
Yeah. Take care, sir.
Yeah.
Yeah, you too.
Talk to you soon.